Okay, welcome to my YouTube channel. And today's video I'm going to look at physics under the topic weight. The main topic here is the mechanics, but we're going to look at the subtopic here, weight. So first and foremost, what is weight? So weight is a force of gravity acting on an object. So the instruments which I use to measure, for measuring weight, we have number one, the spring balance, the bathroom scale. These are one of the instruments which are used to measure weight of an object. Okay, here we are. I'm just zooming a bit clear. Okay. Okay, so the symbol which is used to represent weight in physics, we use the double letter W, capital letter W. That's what we use to represent weight in physics. Then the SI unit for weight, as we all know, is newtons. Definition, I've already defined what weight and the instrument which are used to measure weight. Okay, so this is how the spring balance looks like. So how it works is that you have, let me just remove this. Okay, so here you have the spring which is there, and you have the pointer here on this attached to the string, and you have the scale here. So for instance, if you want to know the weight of this object which is here, down here, let's try to put our own readings. So here, let's say here where it is, where the pointer is there, is 25 Newton. Remember, we said that weight is measured in what? In Newton. So after putting the object on the spring, then this pointer moves from 0. Let's say here will be our 0 Newton there. Then the spring has moved from 0 Newton to 25 Newton. So this simply means that this object here, which we have placed there on the scale, it has a weight of 25 Newton. Hope I then lost anyone there. As I was saying, if the applied objects here, the object you want to measure, you place it on the spring there, then this spring stretches from 0, this is our point here, from 0 up to 25. Then it simply means that this object which you are trying to measure here, it has a weight of 25 newtons. Up there is clear how to use a spring balance scale. So moving on, let's look at okay. So the weight of an object varies from place to place. From the Earth to the moon, those places varies. Rather than mass is same everywhere you go. Be it on the moon, on the Earth, the mass is same. But for weight, it's another different story. The weight if you're on Earth, it differs, and the weight when you are on the moon differs. For instance, weight is less on the moon and more on the Earth. If you compare the weight of an object on Earth and the weight of an object on the moon, you'll see that on the moon the object will have less weight, and while on Earth the object will have what? More weight. So moving on here, there is no weight in outer space. Weight is equal to to 0 newtons in space. Hope that is clear. So let's look at the factors that affect the weight of an object. So number one is the mass of an object. The greater the mass of an object, the greater its weight. Then the second thing is acceleration due to gravity. When G, which stands for gravity, is high, weight is also high. And when G, which stands for gravity, is low, the weight is also low. So distance also affects what? Weight. So distance of an object from the center of the earth. So as the object is moved further away from the center of the earth, weight reduces because gravity keeps on reducing. On the Earth's surface, gravity varies depending on how far the object is from the center of what? Center of gravity. Near to the center of the Earth, gravity is high, and further away from the center of the Earth, gravity is what? Is low. A place at the south or north pole where gravity is 0, weight is also what? 0. As the object is moved clear or closer to the center of the earth, gravity increases and weight also what? Increases. For example, let's look at some examples here. What I'm trying to say in that paragraph is that, for example, this is the center of the earth. Then as you move towards the center of the earth, gravity what? Increases. As gravity increases, also the weight of the object what? Increases. So as you move towards the center of the earth, the weight of that object increases. But as you move away from the center of the earth, gravity does what? Reduces. That means also weight what? Reduces. So I hope you have understand there. So moving on here we have, let's try this example. Explain why the weight of the miner increases as he goes along a deep mine. Explain why the weight of the miner increases as he goes along a deep mine. So the reason why the weight of the miner increases as he goes down the tip of the mine is, it's like this. Let's have here, we have our miner, right? Then we have the center of the earth here. Then this one, the mine is going towards what? The center of the earth. As stated before, earlier on in this video, we are saying that as the object is approaching the center of gravity of the earth, its weight what? Increases. That's your answer to that question. As an object when an object is approaching the center of gravity of the earth, its weight what? Increases. So moving on with B. The weight of the spacecraft reduces as it moves upwards. Of course, this is the center of the earth, right? Then when the spacecraft is moving towards the space, it's actually what? Moving away from what? To the center of what? The center of the gravity of the earth. As it is moving away from the center of gravity of the earth, its weight is what? Is reducing. That's your answer there. Then the equates weight is 0. We all both know that, we all know that weight is 0 weight is 0 in what? In space. So moving on, we have these are the solutions here. Differences between mass and weight. Mass is the quantity of matter contained in a substance, while weight is the force of gravity on an object. So you can even use definition to differentiate the two. These two, even they are units in terms of scalar quantity and vector quantity, you can use them as well to differentiate the two between mass and weight. So the relationship between mass and weight, we know that we know that weight is equal to what? Mass times acceleration due to gravity. In symbols, it will look like this one here. Then where W is what is weight, and M represent mass, and our G represent acceleration due to gravity. So I need to note that the value of G on Earth is what? 10 Newton per kg, while on the moon is 1.6 newtons what per kg per kg. So for example, let's try solving this one example. The mass of a man is 70 kg. What is his weight on the moon? Okay. So first of all, you need to collect data, which is here. Do you have weight? Nope, don't have. Do you have the mass of the man? Yes, we have. Do you have the weight on the moon? So here, we're not supposed to made a mistake here. The author made a mistake. We're supposed to use this one here, like stated before that. The gravity on the moon is this, and we've been asked on where? On the moon, and not on that, on the earth, which is this one here. But if you were asked on the earth, this calculation which were made here could have been what? Would have been correct. But since we are telling us to find the weight on the moon, so this calculation cannot be correct. Reason being, we have used the wrong what? Gravity. So if you want to solve this correctly, you can simply say, okay, weight we know that weight is equals to what? mg, right? Then looking at the data given there, we have the mass of the man is 70 kg here. You multiply it with what? The gravity. But be careful when choosing the gravity. Look where the question I've asked you. Is it on the moon or on the earth? So looking at the situation here, we are on the what? On the moon. So we're going to use this one as our gravity. So it will be 1.6. So when you multiply this, that should be what? Your answer to this question right here. I don't have my calculator. I could have punched in, but I'm sure you understand what I'm trying to put across there. So moving on with the further examples. So in our next video, we're going to look at the center of gravity. Thank you for watching my YouTube channel. Don't forget to like and subscribe.